keep our pH range, we use 6.5 as our low end. We want to keep it between 6.5 and about 9. Okay, so we can do this easily. We use sodium aluminate for the most part. Sodium aluminate is just a little bit harder to handle, and you have to have a contractor that can do that, and you have to apply them simultaneously. So right now, we've only had one contractor that's been able to do this type of application. Luckily, they've done every one of our applications so far, but they're getting really busy with big lake projects. So this gets more challenging. So this is not something, don't walk out there with your golf course pond and just start spraying alum into your pond. You got to pay attention to the pH and some of those other factors that are in there. It's easily managed, and there's other ways to do it. We could use spent lime. There are ways to buffer with some other and use a combination of these tools, which is, I think, the direction we're going to go to make this application process easier for getting these projects done. And then logistically, they can be challenging. It's commonly applied as a liquid. As I said before, that increases our binding efficiency, but you can apply it as a solid if you want. You want to minimize partial truckloads. It costs the contractor more money to have a half truckload to get to the site than a full truckload. So we're always thinking, a truckload's about 4,500 gallons. Can we get, how many full truckloads do we need? How can we spread that across our projects to make this an attractive project for an applicator? So we package those things together to do that. And then a lot of times you need these movable tanks to do that. And I'll show you those here in a minute. So you can see these are the typical application. This applicator has a barge that they can build on the shore. So that duck boat is pushing a barge around in the pond themselves. They carried all the pieces down to the shore and they built that right on the shoreline, and then they went in and did that application. They use a software, it's basically a fertilizer application software. So you see that green patch in there, they're painting the lake. So I can give them a GIS file. I want this many gallons per acre over this area. They load it in their software, and he just goes out there and follows his little screen and paints the bottom of that pond. So we get a nice even coverage that's out there. So it's a pretty cool process. Here's LP53, I believe. So you can see they set these mobile tanks up on the shoreline in the upper left. And they can move those around. So they'll have the truck come by, he'll fill up a bunch of tanks so he can empty his whole truck. You don't want that truck sitting there because it costs money to have a truck sitting there, right? So they empty that there, they put in what they need at that pond, they hook that trailer up, they drag it to the next pond, set it up, and they can move that process all around. It's a pretty slick process. Then they just pump from those tanks down onto their barge. You can see he's using a duck boat with a duck motor. Many of these ponds are really shallow, so it really operates up from the surface of the pond, so they can operate in almost 2 feet of water, maybe even a little less than that. So they can operate in really shallow areas doing these types of applications. And you can thank my wife, by the way, for these photos. She's a photographer, so I drag her to my sites and make her get all these shots for me. And then you can see the white precipitate following the boat. He's out there just painting it around that goes in there. I'm convinced that Jessie Cayley from the city of Eagan can get a boat into any water body that you identify. There is no inaccessible water body for her, right? So we challenged our contractor with the same thing. We're like, well, Jessie can get a boat in there, so we think you can get in there. So JP5 was a little bit harder, where in the upper left-hand corner, you can see you sit up on the road, and then you have to go down this pretty steep slope to the shoreline to get in there. They used a telehandler in the upper right-hand, that orange device. So they actually connected the boat to this telehandler, and it has a long arm that can reach it out. They lowered it down that embankment, and then they got the boat at the bottom and set up and did the application from there. This was before they actually had the barge that they could build on the shoreline to do that. But I think the story that I want you to just know, it's not for the faint of heart, right? It takes some effort, it takes some thought to figure out how to get into these ponds, how to get the application done, and to manage some of those pieces that are in there. So, but the big news is it works, right? So Purnima and Saffold went out and collected release rates from 3 ponds that we have done alum treatments on. The alum treatments were done in 2019, so the blue bars you see are the 2019 release rates that are out there. So it ranged between like 4.5, 5 to, with my glasses, 7 milligrams per meter square per day. It's been zero release, essentially zero release for 7 years since we did those applications. That's pretty good success to get that long. But these are high depositional environments, right? So we expect a lot of burial of that alum layer. We expect to have to go back in and redo this. This is longer than I even expected it to last in these ponds. And we're trying to figure out, how do we predict, we have another study going on where we're trying to predict how long can we expect these to last? What types of environments will they last longer than other types of environments, and figure that part out. So this is just to see what it looks like in terms of clarity. I didn't have great pictures of this, but this is, I think, GP 1.2. So it goes into an iron enhanced sand filter, and you can see that aqua color. That's after we treated the pond that goes into the iron filter. And you can see how clear that water got. All of a sudden, you're seeing all the stuff growing on the bottom and all those other pieces. So it instantly clears up the water in there. So that's just my really quick version of what it takes to implement some of these projects and how effective they are. You know, pond selection is really critical, making sure you get those effective watershed load reductions. Sediment coring, you still got to have it. We're just not there yet where you can do the dosing without those projects. And then application can be logistically challenging, but it is doable from that process. I'll end it there. Thank you.
We have another couple minutes if you'd like it.
Sure. Yeah. Any new questions? You want to do questions, or you want me to keep going?
A few questions.
A few questions? Okay. Yeah?
Can John come up too?
Yeah. Just sit here in our...
Yes, please. Thank you. Do you want to go just till 1:55 still? It's
Yeah.
1:53.
Yeah, just a couple questions each
Okay.
because they're really good. Of course they're
Okay.
So let's just start.
Okay.
Top there.
Okay, gentlemen, thank you again. That was great. First question: through what mechanism do nanobubbles increase pond depth?
Now this is, yeah. So what happens is you're adding so much oxygen to the ponds that you encourage the aerobic breakdown of material. So aerobic bacteria work a lot faster than anaerobic bacteria because they have oxygen, and that works really well to power their activity. So they break down the sediments at the bottom. They break down all the organic matter, and the sediments themselves actually compress. You basically are eliminating organic matter.
Great, thank you. Next question. Joe, the idea that you can over-pond your watershed and create more opportunities to release pee, yeah, mind blown. Uh-oh. I see it here. No, I don't. Okay, sorry. If the phosphorus binds with alum and sinks, what happens to this phosphorus once the pond is dredged? Is the sediment deposited someplace unique?
I'm not sure what you mean by sediment deposited someplace unique. I mean, it just stays bound to that phosphorus. As long as you don't go below a pH of 6 or greater than a pH of 9.5, that bond will be pretty stable in the environment. So even if you dredge it out and you land apply it, it'll stay in aluminum. Most of your farm fields already have aluminum in them. If you buy vegetables at the store, they have an aluminum content. You're eating aluminum. It's the third most abundant element in the Earth's crust. So it just kind of becomes part of that soil profile if you were to dispose of it that way.
Okay, thank you.
Yeah.
Next question. If iron-bound phosphorus is more easily released than alum-bound, should we start building alum-enhanced filter basins instead of iron-enhanced?
That's an engineering question.
Yeah. Well, aluminum oxide is used as a filter, and it's used very successfully. The main thing is costs. To get a good aluminum oxide is expensive. That's why people are using things like water treatment residuals, which is basically the result of alum working on drinking water, alum sedimentation of drinking water. So the water treatment residuals have aluminum oxide in it, and that's why people are purchasing that on the East Coast primarily, and using that as a filter medium. It's a little more difficult because the water treatment residuals are, they need to be dried, they need to be processed, and that adds expense to it. But then, iron filings are expensive as well. So we're actually looking at other materials in a different project funded by the Minnesota Stormwater Research Council, as a matter of fact, looking at different materials aside from iron filing, just because the transport cost of the iron is so expensive.
Interesting. Thank you, John. Okay, one final question. Do you see a situation where intensive street sweeping could entirely replace or eliminate the need for a stormwater pond?
Yeah, that's an interesting one. Yeah, I don't know. It seems like we'll always need stormwater ponds, but we could do a much better job. It's difficult to get absolutely everything off of the streets continuously, right? You can sweep twice a month, but that's not continuous, right? So you have, let's say, for example, you have almost 2 weeks worth of material on your streets, and it rains. Well, all of that's washing into your storm sewer system. So I don't think so. I just think that we could do a much better job with it.
Yeah, thank you, John. So let's give John and Joe a round of applause. Thank you very much.